Day 3, problem 1. This question says, a ladder is leaning against a wall. Its base is 5 feet from the wall, and it reaches 12 feet up the wall. There's a part A and a part B. Now, part A says, sketch a diagram. So we need to draw a picture of a ladder leaning against a wall. And let's see, how about a vertical line? This could represent the wall, and then across here let's show the ground or the floor, and then leaning against the wall diagonally here is a ladder. Now, I'm not the best artist in the world, but I'll try to make this look like a ladder, and here are the rungs on the ladder. Now, I notice when I draw this, it creates a particular shape from math class that we know is a triangle, and specifically it is a right triangle, where the wall and the floor meet is a 90-degree or right angle here. So this is a question that we know in math class as a right triangle. Now it says the base is 5 feet from the wall, so across the bottom of the triangle, this is 5 feet. And we are told that the ladder reaches 12 feet up the wall, and that is this side of the triangle, 12 feet. And so here is a diagram of the situation about a ladder is leaning against a wall, and this is part A of the question. Now, part B says, use the Pythagorean theorem to find the length of the ladder. So we know how far it is across the bottom of the triangle, and we know how long this side of the triangle is, but what we do not know is how long is the ladder itself. How long is this side of the triangle? And we're given the suggestion, let's use the Pythagorean theorem to find this. So for part B, we're going to begin with the Pythagorean theorem. Now, it is a relationship about the three sides of any right triangle, and it can be shown using variables. Commonly, the variables are a, b, and c. The Pythagorean theorem is a squared plus b squared equals c squared. In any right triangle, the letter A is typically the shortest leg of the triangle, and in this case it's this leg right here. This is the variable A, which is 5, so we can put in a 5 for the letter A. Now the letter B is the other leg of any right triangle, and in this right triangle it is this side here, the side with 12 feet on it. So for the letter B I can fill in 12. The letter C is the hypotenuse of the right triangle, and the hypotenuse of the right triangle is its longest side. It will often look diagonal. In this point of view, it is this diagonal looking side, and it's always across from the 90-degree angle. So this side of the right triangle is called the hypotenuse, and it is the side that would be the variable c. And so as we continue here with our equation, we don't actually know how long this is. That's what we're trying to figure out. We can call it, for now, the letter c. So here is an equation, 5 squared plus 12 squared equals c squared, that we can solve. So let's start. 5 to the second power, that is 25, plus 12 to the second power, 12 times 12, that is 144, and that is equal to c squared. All right. Now on the left side of the equals, we have 25 add 144. When we do that, that is 169, and that is equal to c squared. Now we're trying to solve for the letter C. We want to get the letter C alone, And that means that I need to remove this exponent of 2. And the way that I'm going to do that is by using what's called square root. So I'm going to take the square root of the left side of the equation, and the same over here, the square root of the right side of the equation. Now the square root of 169, that is what number multiplied by itself is 169? That is 13. 13 times 13 is 169. So 13 is equal to, and the square root of c squared, what number multiplied by itself makes c squared? That is c. c times c is c to the second power. And so the square root of c squared is c. And so we figured out that the value of c is 13. And so in our original drawing, that side of the right triangle, which is the length of the ladder, is 13 feet. And that is the answer to part B. Day 3, problem 2. There are 3 parts to this. A part A, which asks us to graph figure ABC, and we're given its vertices, so we're given the corners of this figure. A figure with 3 vertices is going to be a triangle. And once we've drawn that triangle, in part B, we're asked to graph its reflection, A prime, B prime, C prime. So we're going to do something to that triangle to transform it and then redraw what it would look like after reflecting it. And then in part C, find the coordinates of the reflected image. So once we've redrawn that triangle, what are the coordinates of its vertices? We're going to need to find the ordered pairs for point A prime and the ordered pair for B prime and for C prime. So let's start. Part A, graph figure ABC. One of its vertices is at A 4, 2. Let's find that. So starting at the origin, the first number in the parentheses is 4. So to the right 4, and then the second number in the parentheses is 2. That would be up 2. So let's see. 1, 2, 3, 4, and now up 2. 1, 2. Here is a dot, and this is point A. Now point B is at 3, -4. Let's find that. So start at the origin. The first number is 3. 1, 2, 3. The second number in the parentheses is -4. So negative meaning downwards. So I want to go down 4 units. 1, 2, 3, 4. Here is point B. And now point C, 1, 1. So starting at the origin, the first number is 1, so I go 1 unit to the right on the x-axis. And the second number in the parentheses is 1, so up 1 unit. And here is point C. And so this figure is a triangle. So I can connect these dots together and show that triangle. There is figure ABC. Now part B asks us to graph its reflection, and this reflection is going to be called A prime, B prime, C prime, and we're going to make this reflection over the y-axis. So let's first highlight the y-axis. Here's the y-axis running up and down on the paper. So in red ink, I'm going to highlight that y-axis. Now what a reflection is taking a shape and redrawing it on the other side of the reflection line, which in this case is this y-axis. So we have a triangle that is right now located here. If we reflect it or flip it to the other side of the red line, it's going to be more in this area of the grid. And we can do this by moving each dot very carefully to the other side of the red line. For instance, here's point A. Okay? If I travel to the red line from point A and keep track of how far it is, then we could just continue on to the other side of the red line, that same amount of spots, and that would locate us the reflection of point A. So let's do that. Here's point A. 1, 2, 3, 4. Point A is 4 units to the right of the y-axis. Let's move 4 units to the left side of the y-axis. 1, 2, 3, 4. Here is the dot that is called A prime. It is the reflection image of point A. And we can do the same thing with points B and point C. So here's point B. Again, let's travel to the y-axis line, which is highlighted in red, and count how far it is. 1, 2, 3. Point B is 3 units to the right of the y-axis. So let's find its image 3 units to the left of the y-axis. 1, 2, 3. Here's a dot, and this is B prime. Okay, now for point C. Point C is 1 unit to the right of the y-axis, and so its image is going to be 1 unit to the left of the y-axis. 1. And here's a dot. This is C prime. And we can connect these dots together, as we did on the other side, and get a triangle. And this triangle is the reflection image of our original triangle. And notice that they do, in fact, look very similarly shaped, that they are mirror images of each other. Now, part C says, find the coordinates of the reflected image. What that's asking us to do is find the ordered pair for this dot, and what is the ordered pair of coordinates for this dot and for this dot. So let's just tackle them one at a time, starting with A prime. So A prime, in parentheses, with a comma separating the two numbers, what are its coordinates? Well, here's the origin. So to get to A prime, we're going to go to the left and then up. 1, 2, 3, 4. It's a little hard to read this number, but this is -4 on the x-axis. And then up 1, 2. So it's left 4 and up 2, or in numbers, -4, comma, 2. Now B prime. Here's the origin, and B prime is down here. So to travel to it, we're going to need to go left and then down. How far do we need to go? 1, 2, 3. This is -3. And 1, 2, 3, 4. That's down 4. Again, it's a little hard to read this number. It's so small, but that says -4. And so the coordinates of B prime are -3, comma, -4. And last, C prime. What are its coordinates? Well, here is the origin, and we would like to find the location of C prime. To do that, we have to go left just 1 unit. That's -1 on the x-axis, and then up 1 unit to +1 on the y-axis. And so its coordinates are left 1, or -1, comma, and then up 1, which is a +1. So here is the answer to part C, where we were asked to find the coordinates of the reflected image.